It is my great pleasure to introduce Dan Ovadya from Florigen.
Hey, thanks so much, Milo and Rosalie, for the invitation. I would like to talk to you today about agriculture. And for me, agriculture is kind of like a novel. It's a journey, and a lot has occurred from something called the Green Revolution, which I'll briefly touch on, all the way to today, which I call the food revolution. And I wish I was talking to you from a greenhouse, but right now with all of the different actually changes in my career, which I'll explain along the way, I'm just going to have a conversation with you and walk you through this journey with information and slides. And the way we'll start is a section on agriculture as an industry in this journey, and then I'll finish with a section on my career. And the career section is actually not about me, it's about you. And I think what we want is for every person on the line to think about themselves and what their strengths are and their ambitions are, and think about how a career can develop, because it developed for me in a very different way. So as Milo said, I am Dan Ovadya. I'm CEO and co-founder of Florigen, which is an ag tech innovation company. And all of us have a long history in agriculture. I was in ag tech for 26 years until I left and founded my company. And I had to fly by myself again. And this is a big change for me. And it's really exciting. It makes me feel like I'm 18 in a way, because I'm learning so much, being an entrepreneur versus a scientist. I'm still a scientist, but I'm having to learn a whole new skill set. But that's what Florigen is. We have an advisory group. We also have a technology group. But I want to go back in time to really what I think is the beginning of modern agriculture, and that's something called the Green Revolution. And it's hard to imagine in this day and age, but there was a time not so long ago in the 1960s where many people on the planet did not have enough to eat, and many more people were dying of starvation and malnutrition. And so the Green Revolution is said to have saved 1 billion people from starvation. And that's why these two people are two of my heroes. Norman Borlaug and Barbara McClintock won the Nobel Prize because they contributed to transforming our entire planet. And the way they did that as scientists was breeding more efficient dwarf varieties of crops: corn, wheat, soybean. They also did it by improving agronomic inputs, which include things like crop protection and fertilizer. And then, of course, coming up with more advanced cultivation methods like machinery and harvesting equipment and planting equipment, et cetera. So this is real, this was transformational for agriculture, and it really helped our entire planet, and our people in so many countries avoid catastrophic starvation. The other thing that, again, this is another person I studied quite a bit. This is a single individual who quietly optimized soybean production in the USA all by himself in a small team. And he transformed soybean from what was a forage crop that they fed to cattle to the #2 crop in the world. And now it's a huge source of plant-based protein. So this single individual had a vision. He was a plant breeder. And he was the first to deploy determinacy genes into soybean, and that helped make it grow better in North America. Without his work, it was really not adapted to North America. It was adapted to China, and it was brought here, and it required breeding to make it efficient for North America. And now it's one of our most important crops. And this one individual with his small team developed cultivars that were eventually planted on 90% of all the southern soybean acres as late as 1990. So it just shows the impact a single person with a real passion and a vision can have on the world, and it can have on society as well, because food is so important to us. That's one other example. Then the last one, as part of the Green Revolution, went modern breeding, modern plant breeding is really important, and it really transformed all of our crops, including crops like corn. And the reason it can do it is simply by creating additional efficiency and yield per unit area or per acre grown. And it's now a multi-billion-dollar seed industry. And back here, this is grain yield of corn, and this is time. So you can see here, corn really made no gain for many, many years, even though farmers and plant breeders thought they were selecting large ears with more grain. They were really making no progress because they didn't understand modern genetics and precision breeding. As soon as scientists began understanding genetics more, like Norman Borlaug and Barbara McClintock, they discovered things like hybrid seed. Hybrid seed completely changed the yield of corn. After years and years of no gain, they discovered the concept of hybrid vigor and heterosis. And this is based on plant genetics, and it dramatically increased corn yield. So again, here's another example of how technology and scientists can transform transform agriculture and actually transform the whole world. Of course, there are problems that are always created with science, but we're focusing here on kind of the impact of science can have. Now, my story kind of begins here. And this is another part of the agriculture story, and that's plant biotechnology. And this revolutionized agriculture in the face of severe challenges. And plant biotechnology means genetic engineering. And it's different from plant breeding, which also modifies the genes of a plant. Plant biotechnology was a new technology that actually is modeled after a natural system of where genes can be modified in a crop to make an improvement. And that's what plant biotechnology is. But there were severe restrictions when I entered plant biotechnology in 1994. And here's the original site in Davis where I began working when I was, 1994. I was 24 years old out of UC Davis. And my first job was running this greenhouse, and I made $8.25 an hour. And at the time, plant biotechnology was considered an emerging field. There were big issues with public perception, restricted markets, regulatory compliance, the influence of big money, and these grain commodity fluctuations. So this was something that I became aware of very soon. You had a lot of progress on scientific innovation, but you also had a very strong movement opposed to this technology. And I will be honest that a lot of the people who were opposed to it were anti-science, and they did not understand the science. They were ideologically opposed to it. And I'm actually okay with that, to tell you the truth. I have trouble when people claim it's based in science when it's not. If someone tells me I am opposed to technology for personal or religious or ideological reasons, I think that's fine, and we should have that conversation. I think it's very threatening to be anti-science and to cloak it in science, if you know what I mean. So this was something I was exposed to very early in my career. And I think the truth is, any aspect of science, you're going to be exposed to some level of opposition, whether it's vaccines, whether it's climate science. The truth is, science is never settled. Scientists always debate and talk about science. And the truth is, I think politics often contaminate science no matter what. So I'll continue on a little bit with the agriculture story, because biotechnology came along and it transformed how we produce seeds for farmers, and genomics, which is really around the genetic varieties that are produced from breeding and biotechnology. And the truth is there were many, many small, tiny companies at a certain point. And there's something which called a consolidation, the same as cell phone market, when really you had all these small cell phone companies, and now there's there's pretty much a couple. You know, Apple went out and bought them all. Well, the same thing occurred at a certain point, and some people say this is good, some people say it's bad, but it is cyclical because Monsanto acquired a number of companies, including the company I work for. Here it is, Calgene, and we were acquired. And so we went through this period of what's called consolidation in agriculture. And actually the opposite is occurring now, and I'll tell you why. But I think a key message here is that biological or scientific innovation creates completely new markets. And remember I talked about corn and corn yield and how much corn yield went up. We had so much corn grain around 2004 that we had to do, and here you have, actually the corn crop percentage used for ethanol. Okay, so I don't know if people know, but 30% of our corn crop goes to making ethanol, which is added to gasoline as a biofuel. And so what occurred here, we had so much corn in North America that a bipartisan group decided to make it mandatory that we use ethanol, thereby and this was called the Energy Production Act of 2005, and this drove an increase in the amount of ethanol required to be used in our fuel. But this was all driven by scientists and plant breeding and genetics and these big innovation gains. So it's just kind of a story on how innovation and science can again transform our society. And today, what the industry of seeds and genomics is now about a $10 billion net sale industry. And these are just grain crops. Well, there's some vegetable seeds here as well. But you can see that there are many, many companies involved with many different aspects. But it's quite a big industry. And it went actually, in the Green Revolution, these scientists really made no money at all. They're very altruistic and self-motivated, and now it's quite a big industry. So let me just finish up here with what's next. There's been this huge industry consolidation, and I think that's driven by the fact that all of these, what I call ag technologies, are kind of saturated. There's no longer this huge growth market. So the question is, what's next? And many things have been tried. And I've seen this actually firsthand from inside the industry. You have gene editing, digital agriculture, topical gene silencing, microbial technology, crop. Many of these things they have tried, but they've not really produced the gains that industry hoped for. So this has kind of forced a reversed consolidation. And that would include me actually leaving the industry after all these years and going out into this new space. And the investment right now in agriculture is shifting towards something called the food revolution. And that's really transforming how we produce food, what kind of food we eat, and how it's distributed. And really trying to improve our diet, make agriculture more urban and local, improve the supply chain so we don't have so much food waste. Providing boutique food or more food selection is very important. And Amazon Fresh is an example of a vertical farm. And these are all hydroponic layers of plants growing here. And I think you have an exercise around thinking about how many plants you can grow here. Amazon Fresh is one of the big companies that wants to change how you buy food and what kind of food you eat. And they will partner up with companies to do this. So this is really cool. Think about this. In Japan, they already have vertical farms running, and each farm can produce 7,000 heads of lettuce per day. And this is how they do it, by stacking these layers up and harvesting many, many crops per year. So 7 or 8 crops per year versus a field in Salinas that only maybe grows 2 crops a year. So this is just kind of an example of a vertical farm. And this is all part of something called controlled environment agriculture or protected culture farming systems. And it's everything from tunnels and shade house to greenhouses hydroponic systems, controlled environment, high-tech autonomous greenhouses, and all the way to vertical farms. So it's really a growing area of agriculture because it allows us to control the environment, and it allows us to produce food in a local way and kind of syncs with these supply chains that allow, it really allows agriculture to offer different kinds of food to people. When you have these greenhouses placed closer to where you live, you're able to grow newer varieties than a variety that needs to be shipped 2,000 miles in a refrigerated shipping container. So this is really exciting for me because you'll see my entire career has been around controlled environment agriculture. So this is kind of what I just said about vertical farming and controlled environment ag. It's a new system. It involves supply chain and marketing, research and genetics, and controlled environment production or farming. And that's what the new ecosystem looks like to me. Okay, now this is about you. And why would you become a scientist? I think I had no idea what I was doing when I was your age. Scientists didn't even come into my head. But when I look back, these are some important points. I think being a scientist means you're inventing things. You're inventing methods and developing products. It's a very creative use of technology. It does involve continuous learning and change, both through industry and as science and technology changes. It really involves sharing ideas with other people and listening. For example, I'm a plant biologist, an expert in controlled environment, but have very, very good conversations with a chemist or with a molecular biologist, and together we can kind of solve problems. And that's really scientists, you're always collaborating, you're always talking, and you're always trying to solve problems, which if that's interesting to you, it may be an area you should consider. So what does it take, in my mind? People always like to see this. So I just have a bachelor's degree. I realized early on that I did not want to go to graduate school. So a bachelor's degree will allow you to really start out in the industry as a research associate. This is the long road, but I often like the long road, and I took the long road. I started at the bottom, and now, in the end, became a science fellow after 26 years. You can also get a master's degree. Many people like it because it's not as committing as a PhD, but it, gives you some additional boost. And actually, the truth is, though, you still come in probably as a research associate, and you probably get some benefit in pay and probably knowledge base, and it could pay off over time. PhD is quite common in the area of agricultural science. That's a PhD, and it takes quite a long commitment. This would mean you would lead a research program in academia or in industry. It requires probably the postdoc training as well, though it's becoming less common to do the postdoc in industry. You can just graduate and come in immediately, and you enter at a very high level in an industry, but you often don't have as much experience than if you did internships, for example. So in terms of modern agriculture and the industry, I think excellent communication is important, written and oral. You have to be able to do it. People leadership is important, and we can all be different kinds of leaders. You can be kind of the quiet influencer leader, or you can be the more extrovert collaborator type, but you have to be kind of organized and manage things well. In terms of technical, strong science background is important. And for agriculture, it means molecular biology, plant biology, developmental biology, production research, which means how do we farm, how do we grow stuff, and plant breeding. That's just an example of some of those topics. There's also all these non-science jobs in agriculture, like finance, legal, engineering, and industry affairs. So you can work in agriculture and not be a scientist, but I think we're talking about science here. Everyone likes to see some numbers, and we don't want to dwell on this right here. But again, as a research associate with a bachelor's degree, you can come in at 50, 60K. With a PhD at an RA level, you're going to come in much higher. If you come in as a PhD scientist or a technical expert, you're going to come in and start around 180,000 and go up even from there. Bioinformaticists, which are statisticians who understand biology, are actually in very high demand, and you're probably coming in now over 200,000. So there's a lot of potential in this industry, and it's a combination of science and other skills. All right, so here's my last couple of thoughts for you. So I think it's important to focus on your talents and be persistent no matter what you do. I actually started when I was 19 years old as a farmhand in Israel, working on a kibbutz, which is kind of like a communal farm. And I'd never done agriculture, but I started there and I kind of fell in love with it. So I went back to Israel and I worked in greenhouses for 2 summers. And those were the most impactful summers. I transferred to UC Davis after these internships, which really helped me decide that I wanted to go into plant biology and agriculture. Then I got my first job in biotechnology as a greenhouse manager. Became, after Monsanto acquired us, a greenhouse lead, and then became lead of several greenhouses. And I kind of thought that was my limit. That was like my upper ceiling, but I really had some coaches and people that helped me and said I had more potential. And so I became a scientist and a discovery project lead, and then eventually became a science fellow. And that's really hard to do without a PhD in this big company, but I was able to achieve it. And then I finished as global crop innovation strategy lead in 2018, and I just exited my career after all that time. So it just shows, like, you know, how much time you have to figure out what you want to do, but keep making progress. Be honest with yourself about what you like doing and what your talents are. Try and have that honest conversation with yourself. I knew I wasn't going to be the typical PhD academic scientist, but I loved what I did and I kept doing it and had a lot of help along the way. All right. And here's my talent. So my talent is around plant growth and development and manipulating plants. And so for me, this all came down to this equation of genotype by environment equals phenotype. So what I was able to do very early on, and people recognize that I was able to change how plants grow and improve their productivity. And that generated over $2 billion for the company I worked for. And it was the most exciting experience of my life. And I focused on my strength. So this was my strength. It's around improving crop productivity as a plant biologist. And then it's something you should think about are your core benefits and strengths. And there's something called this profile where you can kind of think, what kind of person are you? Are you people oriented? Are you task oriented? Do you prefer you know, very steady type work, meticulous work? Do you like best practices and rules and being accurate? Are you really here involved with taking the initiative and driving results? These are actually things that, believe it or not, can help you realize where your talents are and how you can become a great scientist. And that's it. And that's how I, you know, eventually became you know, through my entire journey from the very beginning to the end, I now have founded my own company and I'm CEO, and I have several great partners and love what I do. It's just a different version of what I do. So it's that continuous learning. It's never, so far it hasn't stopped for me. And I think Milo would agree that it is a journey, and it's important to be persistent and be honest with yourself about what you want to do.
Thank you so much, Dan, for such an informative and inspiring presentation. And while students are typing their questions into the chat, I was just wondering if you could tell us about one of your mentors.
You know, I had a, so our company, the first company I worked for was bought by this Midwestern company, which is a really different culture because I'm from California. And so we had this Midwestern company buy us, and suddenly all these leaders, you know, division leaders from the parent company were coming to talk to us. I think one of the most impactful things that ever happened to me was a guy named Bob Bueller from Ohio, who I'd never met, who knew a little bit about me, came out And he sat down with me. And the truth was, at the beginning of my career, I was really, I think I was struggling in a sense because I was so young, about 26. I didn't really have a lot of coaching or leadership. And he sat me down and told me what I was doing well. But then he also told me what I could do if I really wanted to be better. And to me, I always think that's an example of a coach who was honest with me in a very genuine way and said, look, you're doing some good stuff here. And he didn't say you're doing bad stuff over here. He just said, I think you have a lot of potential if you, changed how you interacted with your colleagues, or you did a few things like this, you could be like that much better. So that was really important for me, and actually encourage whenever people go out and look for coaches, that they get coaches who are going to be honest with them, not coaches that tell them just nice things about them, coaches that really care about them. And that means they care about you enough to be honest.
So we have a question from Stefan, who asks, should vertical farms only produce local produce, or is it one of the benefits of vertical farms to be able to grow any produce anywhere?
That's a great question. It's such a new industry that honestly, no one knows what's going to happen. What I'm seeing happening is that, you can, the concept is, because you're growing in a building, is that you can grow any crop anywhere. That's the technology behind it, meaning you could literally grow strawberries on the moon if you wanted to, because it's completely contained in a building and it's not affected by the outside climate. But does that really make sense, and can we afford that? So I think what's happening right now are that in these things called megacities, like in China or Asia, especially, where you have no local land, and especially there's a lot of environmental degradation, and clean water is a problem, that in megacities, what is happening is that these vertical farms are being put up to provide clean, healthy food in a local kind of way. And a lot of it starts off with leafy crops. There's a lot of interest in strawberries, and there's some interest definitely in fruiting crops like tomato, pepper, and cucumber, and melon. I think it has a long way to go. The idea is to actually grow any produce anywhere. The real question is, how much is that going to cost, and what will people pay for it?
Aaliyah is wondering, how long is the regular time needed for a crop yield compared to the accelerated growth period?
That's a good question. And I know these vertical farm companies are trying to compare lettuce production in a vertical farm to open field lettuce production in Salinas, for example. And so in Salinas, which is south of Santa Cruz on the coast, where they grow huge amount of this country, of the entire country's lettuce, along with Yuma, Arizona, they produce about 2 cycles a year of lettuce. But their big heads are like 1.5 pounds each, sometimes, these heads of lettuce. So a vertical farm is saying they can get 8 cycles of lettuce a year, but the heads may only be 120 grams. So it really is changing, again, like how we think of food and lettuce. So it's interesting, in Asia, or a place like Singapore, which has a lot of money and a lot of energy and no land, they want to have food security. They don't want to rely on importing all their food. So they're subsidizing vertical farming. And the way people in Singapore buy food is that a lot of them live in apartment buildings. And at the base of the apartment building, they have a small market. And they can go to that market and they can buy a small 100-gram head of lettuce in their apartment every day, and they consume the entire thing. They don't, put the lettuce in the refrigerator and eat it over a week. They just simply buy a single meal's amount of lettuce whenever they want it. And so that's just kind of the potential and the different way food can occur.
So Carrie is wondering, before you had your own company, did you see any kind of hierarchy or superiority complex from your colleagues with PhDs or master's degrees? Or were you treated as an equal colleague despite your bachelor's degree?
Yeah, absolutely. For me, there was a bias against people who did not have PhDs for sure, and several of my inventions really were dismissed early on because I did not have a PhD. On the other hand, I had a couple of people in the company who really believed in the technology, and they were able to actually coach me through this and say, look, don't let that perception affect you. I think you still have to be data driven. And it actually, what it did was it forced me to be even better than I would normally, because I had to convince people with data, because I didn't have the full PhD background. I think I had to be even better at understanding the technology and the data in order to have it be accepted. So yeah, to tell you the truth, it was my own kind of glass ceiling that I had to deal with, both internally, I mean, having low confidence because I didn't have a PhD and believing in myself, and also, you know, getting my ideas out there. It did make it harder, but in the end, that's where I think persistence is very important.
Mhm. Sophia is wondering, does vertical farming use less or more resources?
Oh, that's an outstanding question, because vertical farming industry is saying they use way less resources, and they're getting hundreds of millions of dollars in funding because they're saying they're going to save the planet. I think as a technical expert, I would say the answer is yet to be shown. And there's many ways to kind of measure resources. I will say this, it can definitely use way less water, because the water used in hydroponics can be recycled, and even the air and even the transpiration from the plants can be collected in the form of liquid water and reused. So I think it's clear that you can save a lot of water by using any type of recirculating hydroponic system, whether it's a vertical farm or a hydroponic greenhouse. On the other hand, because there's no light in a vertical farm, even though LED lighting is extremely efficient and getting more efficient, I cannot say it's more efficient in terms of energy usage. And there's no comparing to the sun and free light that you get, which is a key to photosynthesis and all crop production. So I would say they have a lot of work to go in terms of energy uses, in terms of heating, cooling, and lighting. They are saving, I would say, land area because of those vertical layers, and I'll say that they're saving in water.
Riken is wondering if you could grow taller / more unusually shaped plants using vertical farming. Could you say grow corn where the stalks overlap each other in a hydroponic / aquaponic farm?
I love that question. Architecture is just an outstanding concept. So plant architecture is huge, just like we gave the story of soybean and determinacy, making a plant short. You should really go to Holland sometime and see how they grow these indeterminate tomatoes. It's called the highline system, and they grow 20 feet, 25 feet tall, and they just keep flowering and adding new tomatoes. There's so much you can do with plant architecture. It's really, really important. So the answer is yes. I mean, in terms of your idea of corn, we may not be growing corn in a vertical farm. We may still continue to grow that in the field, but in terms of all these other crops, plant architecture is so important. And that could be something like, wow, I have this vision of creating tomatoes that instead of growing 20 feet up, they grow 20 feet sideways. And that way we can stack them horizontally, and that way we can automate the harvesting. And another example would be, broccoli that has a very long stem. So it's automated harvest. Instead of having people out there bent over with knives in the field, that you could automate something like that. So it's a great question, and we definitely need more people thinking that way.
Well, Jake asks a related question. Do you believe the future of agriculture will be completely automated?
Yeah, not completely automated. I think there will be a tremendous amount of progress with automation. I'm dealing with this right now with some of our client companies where you have all of these engineers from Tesla, that have maybe come into agriculture and said, okay, I want I want to eliminate the need for a human farmer, and I want to be able to just press a button and grow my food, and we never need people, right? And the truth is the biologists are over here saying, no way, that's never going to happen. We need people to breed and to modify plant architecture so the automation works. So it's interesting right now. There's all these different perspectives, and I actually think it's cool and okay for people to have like a really biased or narrow view and to kind of pursue their dream of completely automated agriculture. But the truth is the biggest innovation occurs when like an engineer talks to a biologist and they come together and they realize, okay, no, we're still going to need farmers. We're still going to need pilots to fly these farms, and we're still going to need people to look at them. And we're still going to need breeders. And yeah, the automation is important, but they're still going to create a ton of jobs and people out there. They're just going to be different jobs, and I think hopefully safer and more ergonomic.
Well, Stefan is asking another related question. How long will it take to install vertical farms? How hard will the transition be, accounting economy, time, jobs, and location?
Oh, totally. So I know one project in Brooklyn, New York, building one of the biggest vertical farms in Brooklyn, New York, which is like a very busy, expensive, crowded, hard to function city. And just the plumbing alone is taking a year to put in the plumbing for all of that work. And it's a ton of money. We're talking like maybe $800 a square foot to finish the vertical farm. And you compare that to like $150 a square foot for a high-tech greenhouse. So it depends on the size of the farm. The big factory farms can take, 18 months easily to build. They're really expensive. Another aspect of, vertical farming or plant factories are these shipping containers. And a lot of companies are offering these shipping containers that have these hydroponic racks in them, and you can just simply order them and put them in the parking lot, and you could service like a series of restaurants, let's say in a ski town where you can't get fresh, leafy greens locally, but you can get one of these shipping containers and they're pretty cheap. And you can actually grow a lot of food in a shipping container and serve, a very small local community and have good food.
Here's another related question. Rosalie asks, do you have any thoughts about how vertical farming can help populations in more disadvantaged areas in the US and beyond? And a follow-up, do you think vertical farming could help mitigate the effects of climate change?
Yeah, so on the other, I think right now vertical farming in particular, which is completely in those indoor farms with LED lights and hydroponics, right now I don't see that applying to developing areas. I think where we're seeing it right now are countries that have these very big cities and there's enough government support to help build these very expensive farms, because having fresh food is so important that they can afford to do that. And we're seeing that in places like Saudi Arabia, where they have no water, Singapore, where they have no land, or China, where they really don't have any clean, or they don't have the transportation infrastructure in a mega city. In terms of climate change, it's hard for me on I would say, high-tech greenhouse glasshouse has a better opportunity to be more efficient than a vertical farm, because greenhouses have natural light. They just get all that free sunshine. And so they require way less energy than these vertical farms. And so because vertical farms rely only on LED lighting and no natural light, that's going to add up and be a really, really big, energy cost. And the truth is these farms, they're made out of plastic and steel and electronics, and they do depreciate over time. And after 8 to 10 years, guess what? Odds are you're going to have to rip all that stuff out and throw it away and build a new one. And that's going to be hard to imagine that that's going to be good for the environment or the climate. So they have some real serious challenges.
Stacy and Liam ask, do you have any plans in regards to soil depletion, or what is your take on that?
Yeah, so I think my dream would be, okay, soil depletion in the field, in a farmer's field is a big issue. And remember I said that 30% of our corn crop goes to ethanol. And ethanol in our country really doesn't have a benefit, an environmental benefit per se. It doesn't really help to, reduce number of miles, driven by people. And so, I don't know, I started thinking like, okay, wow, 30% of all our corn goes into the gas tank. So you can go down and, buy yourself a drive-through burger. Is that really a good use of our soil? Maybe we should just not use ethanol and put 30% of the land back in to recover, right? That's kind of one thing I think about in terms of broadacre farming. In terms of controlled environment farming, there's no soil used. It's hydroponic, which means there's no soil involved. So in that sense, controlled environment agriculture is great because it's very intensive. You get multiple harvests and you're not using any soil.
So we have time for two more questions. Carrie asks, is there any way to make more permanent or long-lasting vertical farms, similar to permaculture?
Yeah, I bet people are thinking about that. LED lights can last approximately 30,000 hours of runtime, but it sounds like a lot. But when you start thinking about running the lights 365 days a year for 16 hours a day, it's actually not that long. It might be like 7 years before you have to like literally take all those LED lights out and install new ones. So that's one challenge. But I think that's an opportunity, it sounds like, for one of you to to figure out a solution to that. I think anything that doesn't depreciate and last longer is part of sustainable agriculture.
Aaliyah is wondering, does vertical farming have any downfalls that could hurt consumers or the environment?
Yeah, really interesting in terms of perception. In France, they're actually not as interested in vertical farming. In France, people still want their lettuce to come delivered by a farmer on their bike in their basket. And they want to be able to, see a little dirt on it and think it came from a small farmer's market. That's kind of what in Europe, what is the model. In Asia, they love the concept of kind of robotic food, very sterile food that has not been touched by any people. And so there's very different cultural, priorities between what consumers want. In terms of can it hurt, I don't think there's anything here that would hurt. In fact, vertical farms claim zero spray food. So not even organic, where they use organic pesticides. They're talking about no spray at all. So consumers, I think in Asia, for example, vertical farm food is the highest, cleanest food. It's even better than organic. In terms of the environment, I think we have to be careful again anytime we build this much infrastructure, and what happens when it's finished. Are we going to just tear it all out and throw it away? That's one of my bigger concerns.
I'm going to squeeze in one more question from Riken. Have you seen many designs where vertical farming is hybridized with greenhouses or maybe polytunnels?
Yeah, I love hybrid systems. They're great. The one thing about vertical farming that makes it tough in a greenhouse is the vertical stack, right? Because as soon as you start stacking layers, then the lower layers get no natural light, which means you would have to add light, which means you're basically just doing a vertical farm in a greenhouse. So I'll say that there are many other, I think, technologies from vertical farming that could be used in an automated greenhouse, like deep water culture, or carousels that transport hydroponic trays very, very efficiently. Polytunnels are great because those are low-tech solutions that are actually very inexpensive to install, and just add like a little protection from bugs or wind or too bright a sun. It's used really well by a company like Driscoll's, which produce all these berries up and down, from Mexico all the way up to North America. So I will say that there's continuous exchange of ideas going all the way from very low-tech polytunnels to mid-tech glass house to really high-tech vertical farm.
So I think we're ready to move on to our design organizer. And do you have any tips for students as they design and make a model of their own vertical farm?
I think my tip would be have fun with it and think of any situation or any place you've ever been or anything you want to eat. I mean, really, this is what it's about. In a vertical farm and controlled environment, theoretically, you can grow anything you want. You could grow bananas in British Columbia if you want. That's the potential here. So I would almost say, like, don't worry about being realistic. In a way, be completely imaginative about it and solve a problem that matters to you. That's, I think, the most exciting thing. Like, if you could grow, like, what's your favorite food and where would you want to live, and design a farming system around that. Let's say, again, yeah, I know Milo and I love skiing, so let's say, you want to eat really sweet strawberries, um, when you're up in Alaska skiing, and you want to, come out and have a delicious, delicious local strawberry smoothie after you skied powder all day. Design that system.
Cool. Well, thank you so much, Dan, for taking us on this journey.